Hello, everyone. My name is Chris Brown, and I'm going to take a little bit of time to go over U4 communication fault codes on Daikin mini splits and multi ports and troubleshooting of those. The U4 fault code is a communication error, communication problem between the indoor and the outdoor unit. The indoor and the outdoor unit can't communicate. And a good bit of time, I would say these fault codes are the result of improper wiring. Just physically, the wires aren't landed where they should be. So if you have a U4, especially if it's on a new install, physically look and verify that your wiring is done correctly. That means is you're going to make sure you have L1 and L2 go into your outdoor unit, and then from your outdoor unit, you're feeding L1 on 1 to indoor unit 1, L2 on 2 to indoor unit 2. You now have a 3 wire for your communication for your signal. 3 goes to 3, and ground, of course, is attached. These wires, these interconnecting wires, are typically color coded, so simply match the colors. If physically everything looks like it's landed in the right spot, make sure you have the right type of wire. It has to be 14 or 16 gauge stranded, non-shielded. Stranded is important because this 3 wire carries DC voltage on it, and it just simply carries better on stranded wire. Solid core wire is more prone to nuisance U4 faults. It's important that it's not shielded because that shield jacket acts as an antenna that draws an interference on the 3 wire, again leading to nuisance U4 faults. If you do end up with shielded wire that you can't easily replace, take the one end of it on the outdoor unit and ground the shielding jacket, and then leave the indoor unit portion ungrounded, leave it detached. That typically will resolve those nuisance U4 faults. You also have to look and see if you have any accessories or any, especially condensate pump on these units. If you have a condensate pump on your indoor unit, you need to make sure it is wired properly. And you have to be careful because a lot of the literature, the wiring diagrams for those condensate pumps tell you to break the 3 wire through the float switch, through the auxiliary contacts. And that's absolutely incorrect. The only wire that you can break through any kind of auxiliary contacts or float switch is your L1. You can't break 2, you can't break 3. And the reason for that is the 3, for lack of a technical term, is very fickle. Any additional resistance, any additional connections in this 3 wire can lead to nuisance U4 faults. And 3 uses 2 as a reference, so anything you do to 2, you're also doing to 3. Okay, so again, L1 is the only thing that we can break. So 2 and 3 from the outdoor to indoor, that should be a 100% complete, unadulterated run of wire for these two. All right. But now, if our wiring terminals are correct and we have the right type of wire and our accessories are wired properly, and we're still getting that pesky U4, go move on to your AC voltage check. So grab your meter set to volts AC, and you're going to go L1 to L2 coming into the outdoor unit. And you should have your 208, 240 up here. And then L1 to ground would be 120 volts, and L2 to ground should be 120 volts. You absolutely must make sure you go across L1 to L2 to make sure you got 240 in addition to the ground checks. The reason for that is if you have 3-phase and both of these are on the same leg, or if you're using split phase and both of these are the same side of that split phase, you'll get 120 to ground, but you'll get 0 volts across. And that doesn't work too well. Then you need to repeat that check at the outdoor unit power leaving to go to the indoor, right? 240, 120, 120. And then here at the indoor, 240, 120, 120. If line voltage check's okay, check your 3 wire, 2 grounds. You're looking for 80 to about 100 volts AC. 80 to 100 volts AC. And if you go from 3 to 2, you'll get about 20 to 40 volts AC, 20 to 40 volts AC. The reason that those are weird numbers is, remember I said 3 uses 2 as a reference? It does, but the 3 wire, that voltage is processed through the communication bus on the boards, and there's voltage drop through that. So even though it's L2 is L3, or would be the same potential, they're not, because when you measure it, you're actually seeing that voltage drop. So you get those, 80 volts, 40 volts. That's perfectly normal in a fully functional system, though. Now, if our line voltage checks are okay, what I would recommend doing then is go to your outdoor unit and look for that flashing green light. If that outdoor unit has the flashing green light on the main board, the heartbeat light, skip this part. If you do not have that flashing green light, you then need to figure out if your outdoor unit has an MR30 relay. That is an energy saving relay that is closed by the indoor unit's activity. And if there's no activity for a certain amount of time, It'll open and the whole of the outdoor unit will shut off, including that heartbeat light. Now, how do you know if you have an MR30 relay? Well, the best and most surefire way is to look at the wiring diagram, and you will see wired in series on the outdoor board on the wiring diagram, MR30, little relay picture. All right, wired in series with 3 on the outdoor board. Also, physically look at the outdoor board itself, and on the PCB, you will see a little spot that says MR30. If there's a little black relay box on that, that means you have an MR30 relay. If there's just a stainless steel jumper there, it means you do not have an MR30 relay. Be very careful. Make sure the wiring diagram, if it shows you have an MR30 relay, you physically verify you have an MR30 relay. If you do not see one on your wiring diagram, make sure you see that stainless steel jumper. If they are crossed, you may have, so if you have the jumper but the diagram says you should have the relay, you might have the wrong board in there. And obviously that doesn't work too well either. So if you've gone and you do have an MR30 relay and you do not have that little green light, go to your indoor unit and turn on the fan. That counts as activity, and that will tell the indoor unit to wake up the outdoor unit. If the green light comes on with the fan coming on, keep moving. Okay? But if that green light does not come on with this fan running, then that means we've got some kind of problem, probably from this point on up to here. Okay? But we'll get to that. Now, if we do not have an MR30 relay, and we do not have that little green light on here, and we've done our AC voltage checks, we've got a problem out here with the outdoor units. So what I would recommend doing then is make sure these wires on the factory side, so all your factory wires back to the board, like your L1, your L2, your 3, make sure they are all wired properly to the board. A lot of times it's a solder connection, but sometimes it's a plug. Make sure the plug is seated properly. Make sure it's tight. Make sure it's clean. There's no corrosion. Make sure everything here matches. If it's a multi-port, you'll have a whole bunch of factory connections on the back side of your field connection terminal blocks. Make sure those are all done properly. But if we verify that our factory wiring is correct, we don't have that green light, go to your outdoor, turn power off, disconnect the big 4. Compressor, expansion valve or valves, 4-way valve, and your outdoor fan. And then reapply power and see if we have the green light. If the green light comes back, one of those components or more than one is failed, and you probably have a small short in it that's robbing current from the board, but it's not enough of a short to start popping fuses or breakers. Okay? But what you're going to do then is you're going to go to your service literature, you're going to look up the checkout for those components, you're going to check each one of those out, and you're going to make sure that you find the one that's causing that board to act erratically. Now, if you disconnected all of these and we still don't have a green light, well then your board is bad. But you still need to do the checkout on these, because if you have a bad board, it's possible one of these 4 components or more than one have failed, and when they failed, they took the board with it. So that's what you're doing if you do not have an MR30 relay. But going back, if we do have an MR30 relay, okay, and turn the fan on didn't solve all of our problems and make the U4 disappear and the thing run, regardless of whether we have a light on or not here, this check is going to be the same at this point. We have to again go to the indoor unit to start our checks, because remember, on an MR30, it's an energy saving relay in the outdoor that gets woken up by the indoor activity. So we start with the indoor. The indoor initiates communication protocol. So we go to our indoor. We're going to disconnect our 3-wire. And I just want to take this time actually to say, all this talk about disconnecting wires and putting them somewhere and doing these checks, make sure that when we're got our fingers in there, we have power off. And then when we put the wires somewhere, we're putting them somewhere safe, and we're taping them if need be, right? Because we don't want to short anything out, and we don't want to hurt ourselves. So just use some common sense there, please. Because a lot of this troubleshooting is live troubleshooting. So with that being said, go to your indoor unit, and you're going to check from 3 to ground on the indoor unit with the 3-wire interconnecting wire off, tucked somewhere safe. And from 3 to ground on the terminals of the indoor unit, you should see 54 volts DC. 53 to 55 is acceptable. If you see 54 volts DC here, the indoor unit is doing what it should to try to talk, to try to communicate, and you can move on. However, if we do not see 54 volts DC here, you're going to unplug your fan motor, recheck. Did it fix itself? Do we now have 54 volts DC? If we do, it's a bad fan motor. If we still don't have 54 volts DC here, we're going to check our factory connections from all our terminals back to the board. But if those are correct, then we have a bad board. And if we have a bad board, we're still going to check out our fan motor because the fan motor may have failed and taken the board with it. Again, just to go over this, make sure you get it. 3 to ground on the terminals on the indoor. If you have 54 volts DC, move on. You're good here. If you do not have 54 volts DC, you're going to disconnect the fan motor, recheck. If you now have 54 volts DC here, the fan motor is bad. If you still don't have 54 volts DC here, check your factory connections back to the board. If those are good, the board has failed, and you still need to look up the service literature factory checks for the fan motor because the fan motor may be bad and could have taken the indoor unit with it. Okay? So let's say we do have our 54 volts DC there. We're going to reconnect everything. And we're going to go to the outdoor unit and disconnect the 3 wire from the outdoor unit. Then we're going to turn power on. We're going to turn the fan back on. And now we're going to check this wire that's now hanging, that's coming from the indoor. We're going to check on that 3 wire to ground. And here we will see a voltage DC greater than what we saw here with that disconnected. So remember we saw 54 volts DC here with this wire off, with the 3 wire off. Up here, well, we've since reconnected this, right? Up here, we're going to see a greater voltage in that. So it might be 70 volts, 80 volts, 90 volts DC. It cannot be above 100. If it is above 100 volts DC, you probably have some kind of short. But if it's 70, 80, 90, that's good. That means from this point back, including the indoor, we're good. If you see less than what we had here, you probably have some kind of broken wire, or maybe there was like a splice or a field connection you didn't know about in the interconnecting wire that we don't have a good connection through. Okay, and the reason you see more is because you now have the added resistance of this wire in this check, and the unit it's basically pushing a higher voltage to try to compensate for that added resistance. Okay, but if we have proper voltage here, 70, 80, 90 volts DC, that means up to this point, we're good. So the problem is in the outdoor unit. Now, again, we are checking our factory connections here, making sure everything going to the board is where it should be. Everything is tight, clean, no corrosion. If it's a plug, making sure it's plugged in properly. But if all the way up to the board, that's good, then that means the board is bad. And if the board is bad, you're going to check out these big 4 components using your service manual, because one or more of these may have failed and taken the board with it. Okay, so that's how you check out a system that has an MR30 relay. Now, what if you don't have an MR30 relay? And here's just a little bit of a quick tip. Systems that don't have an MR30 relay, any multi-port, an MXS, an MXL, they do not have an MR30 relay. If it is a system that has the FFQ cassette unit or the FDMQ concealed ducted unit, it does not have an MR30, because those, the concealed ducted and cassette, they don't have the relay in them to wake up an outdoor unit, right? And because the multi-ports support those, they don't have an MR30 relay. Otherwise, it's most of the one-to-one wall mounts, the high wall mounts, do have an MR30, but we're going to physically verify the wiring diagram and the board to be sure, right? Because that could change at any time. So now, if we don't have an MR30, and we verify that, we do roughly the same checks, but slightly different and in reverse. So we actually start with the outdoor unit, and this time we're going to disconnect 2 and 3. And again, we checked our wiring, we checked our AC voltage. We're going straight to DC voltage. And with 2 and 3 off the outdoor, check the outdoor. Do we have 54 volts DC here? If we do, the outdoor board is doing what it can to communicate. The outdoor unit is okay. If we don't have 54 volts DC here, we're going to reconnect and disconnect. We are going to, okay, let's back that up. Okay, 54 volts DC, we're good. We do not have 54 volts DC. We're going to disconnect the big 4. Do we have 54 volts DC here? If we now have it, that means one of these or more are faulty, and we need to do the service manual checkouts for these. If we still don't have 54 volts DC here, verify factory wiring to the board. We verified that. That means the board has failed. We're still doing checkouts on these because one of those may have failed and taken the board with it. Did I say that enough yet? I've said that so many times, but it's true. Boards don't often fail on their own. They very rarely fail on their own. They're killed by something. And if you don't figure out what killed it, when you put the new one in, turn power on, you're going to let the smoke out of that one too. All right. Well, we got our 54 volts DC. So we're going to reconnect our wires. And then we're going to go down to the indoor. We're going to disconnect 2 and 3 from the indoor. And we're going to check the ends of the wire hanging there. Do we have 70, 80, 90 volts DC? Do we have whatever this was a little bit higher, less than 100 volts DC? If so, the wiring is good up to this point. The problem is in the indoor unit. Okay. And again, if it's over 100 volts DC or it's less than we have here, we got a problem probably with the interconnecting wiring. And again, what I would do is if we think we're good here and we think the problem's in here, we're checking our factory connections. I would try, if we haven't already, disconnect the fan, hook everything back up. If it still doesn't run, at this point, you probably have a bad board, and I would do the fan motor checkout to make sure that didn't take the board out. If it runs like this with the fan motor disconnected, well, then you probably got a bad fan motor. Now, there is one little exception here to the no MR30, and that is on the LV3036, aka the Polara series. They used to call it LV3036, and now calling it Polara with the newest series, the newest revision. But this is the big cooling only one-to-ones with the wall mounts, the real big indoors. On these, we're doing something very similar to the MR30 check, except this does not have an MR30 relay. Okay, this does not have an MR30. However, we do start at the indoor. We still check 3 to ground with the 3-wire disconnected. But now, from 3 to ground, we will have between 12 and 54 volts DC. Okay, so 12 to 54 volts DC here. And again, the same rules apply. If we don't have it here, disconnect. Boy, I don't plug anything back in. I probably get all kinds of callbacks. If we don't have 12 to 54 volts DC here, disconnect the fan. Do we have it now? Yes. Bad fan motor? No. Factory connections. They good? All right. Bad board. Double check the fan. Okay. If we had 1254 there, reconnect. Go to your outdoor. Disconnect 3. You see, this is all I've done before. The numbers have just slightly changed. Then 3 wire to grounds. Has to be more than we saw here, less than 100 volts DC. Okay, so that could be a lot. That could be 30, 40, 50, 60 volts DC. Okay, and at that point, if this checks out okay, we know the problem is in the outdoor, right? And we're going to disconnect everything. If it doesn't work with that stuff disconnected, the board has failed, and we're still going to check that stuff out because that could have killed the board. If we disconnect all the stuff and it does work, then one of these is still probably failed. All right, now one more thing I want to go over here real quick is, remember how I talked about you could have a shorted wire or a broken wire, something like that? How do we check that? Well, obviously, you can do a continuity check for broken wire, and that's real easy. What most guys will usually do, you can go indoor or outdoor, but let's say we go to the outdoor, and you can simply turn off all power, pull these off the outdoor unit, and then you could, for example, just take L1 and L2 and wire nut them together. And then you could take 3 and ground and wire nut them together temporarily. And then go to your indoor unit, and you would pull these off the indoor. But see, we made 2 big wires, and we would check resistance here. We would check continuity here. And you should have minimal continuity, right? If you have a ringer on your meter, you'll hear it ring out. That basically means that both these wires have continuity. Feel free to give those little jiggle, pull, tug, whatever. Because if you've got a broken wire, it may not be broken all the time. Sometimes it can actually kind of like push itself up against the 2 ends, and you'll have continuity again. But you're going to ring out the wires, if the wires ring out okay, maybe we have a issue with the quality of the wiring insulation. All right, and this gets a little more in depth, but it's good stuff. So I'm gonna take a moment here to reconnect all my wires. I'm doing this in a very poor way. No wonder my boss is mad at me that I take too much time on jobs. Now, if you look at the factory instructions for how to check your wiring insulation quality, they want you to use a Megger. And what they want you to do is they want you to disconnect line voltage from the outdoor. So you pull your disconnect. And they want you to disconnect 1, 2, and 3 from the indoor. Leave ground intact. And you're going to take your Megger and you're going to compare each line to ground. And they want at least 10 megohms of resistance. And if you don't know about Meggers, a Megger just pushes, in our case, we want 500 volts. They're pushing 500 volts through these wires, and they're checking to see how much of it they pick up on ground. And if it picks up too much, that means we've got an insulation problem. So it's measuring resistance by doing that. And if we get less than 10 megohms, 10 million ohms of resistance, that's not good for the wire. That's not good for the system. That's not good for communication. Now, the problem I see a lot is most guys don't have a Megger. All right? It's a good tool to have, but it's expensive. So maybe you only have your meter. All right. Well, a meter, although for this purpose maybe isn't quite as good as a Megger, it's not. But it still tells you something. And it's still worth doing. Meters typically use like a 9-volt battery. So we've gone from 500 volts of force to 9 volts of force. But we can still check these wires to ground. Now, I cannot tell you what the manufacturer says is acceptable checking to ground for resistance on a 9-volt meter because they don't publish that. They only tell you what they want with a Megger. But I can tell you if you're reading anything less than multiple megohms, and especially if you're having communication problems and you can't find anything else wrong, I would probably replace this interconnecting wiring. And if you're picking up, kilo ohms, like thousands, even hundreds of thousands of ohms, or even less, with your 9-volt meter, I would replace that wiring. Another check that I do, but this one actually isn't in any of the literature that I found, but I would recommend, you can have these wires shorted to each other, right? So what I would do is I would disconnect both ends, so you have wires floating free on both sides, and then check your meter, check resistance from wire to wire. And you should probably be in the megohms. If you're in the kilo ohms or less, I would run new wire. I had one not real long ago where we checked, it was throwing a UA for system incompatibility. The idea was, I guess, the indoor and the outdoor aren't compatible, but they were, and the boards were right, and everything was correct. And, we couldn't figure out what was going on, and we were getting very weird voltages when we were doing our communication voltage checks. So I said, well, let's check our wiring. So we isolated and we checked 3 to 2. We had like 250, 300,000 ohms. And it was like, well, what? That doesn't sound right, because you're pushing through 2 layers of insulation on that. So they ran new wire, and the problem resolved. Never heard from them again. So definitely recommend, even if you don't have a Megger, use your 9-volt meter. Check these to ground, but also check them to each other, and I would isolate them when you're checking them to each other, because I don't have a proper checkout for you from the manufacturer for that. So isolate it just to be safe, just to make sure you're getting a good, accurate reading there. And then last little tip here, if you ran new wire and you end up with a U4 that you think is something in the wire, like it's a break in the wire or it's poor insulation, abandon that spool and go get a new spool of wire. Because odds are, if that was a dud, there might be more duds further down the spool, right? And you're just going to end up with a problem further down the road. Or worse, you think you did that, so you say, oh, it's not the wiring, I put new wiring in and it's the same problem. When actually you were onto it, you got bit twice. So hopefully that made some sense to you guys. I appreciate everyone taking the time to watch this video, and hope everyone has a great day.